Boy howdy, here we are, end of the CCNA1, got a big packet tracer in front of us. I'm using the tools in my Word document. I have it copied out here, and I always start with the addressing table to get everything we know in first, and so that is where I'm starting with this one. I kind of changed some of the names, so hopefully if you guys are just using this as a guide when you are doing it from actual Net Academy assessment, the names aren't too messed up, but hey, it's good for you to have to think anyhow. So first thing we're going to do is we're going to go into the Town Hall router, and I think I'm going to start off by saying, well, we have to enable it, and then we say conft host, or host name. I'm going to say, I don't know, Town Hall router. It might, I think it tells us what to call it later, so we'll just say Town Hall for now. And anyways, we go into interface G00, and we only know the IP version 6 addresses, so we're going to say IP version 6 address, 2001 DB8 ACAD, A for the A VLAN, and the first address that's usable, 1, and then /64 is what we do right there on IP version 6 address. Alright, and we're going to go no shutdown because we can see it was red, so we're going to turn that on. Now we're going to go into interface G01 and say IP version 6 address. And the neat thing about this is they're all the same, so I'm just going to up arrow and change B in the subnet and do a no shut as well. And so there we're pretty good. Actually, no, we have to go back into both of those, and actually just one, into interface G01, and we say IP version 6 address, no, yeah, FE80, which is the link local prefix, but instead of putting a prefix, we say link local. Okay, so we've set the link local on there. That's what we know in that first table. So now I'm moving on to the host. So I have reception host, and so I'm going to go to the desktop here, go to the IP config, and go to this IP version 6. Our reception host has a 2001 DB8 ACAD A FFF for the address, and then we're going to go /64 in there because that's what we did on the last one. And I'm just going to put in a default gateway right now, and we're going to go FE80. Actually, no, these ones, do these ones not have? We're just going to do it anyways. FE80, I think it tells us to do this later, ::1, because I believe, is this G01? Oh, it is not, so we didn't set FE80 there. So we'll leave it blank for now, but we could just do, I'll do it. Even if it doesn't ask for it, we're doing it anyways. :1, then we can get out of there with IP version 6. Now I'm going to go to the operator, do this a similar task, right? Our IP configuration, and we're going to say, I'm actually going to paste in what I put there. Gives me the A column there, but this one is 15 for operator host. Paste it in again. 1, make sure we put a subnet prefix of /64, and we're good to go. Okay, so now we have that side. Now I'm going to PC2. And once again, you guys, if you guys are, it's this chart right here that I'm going from. And actually, if you're doing it this way, oops, pulled the wrong document back. So we'll go like this. We could actually probably just copy from here into there. That is one nice thing about doing it this way, but I do prefer if you do it through the actual packet tracer assignment on NetAcad. And this one, FE80 ::1 can be our default gateway because we set a link local, so the link is basically just this LAN, right? Because this is layer 2, so they don't see it, so these computers think they're directly connected to there, and we set G01 be FE80 ::1, so it can be FE80 ::1 on that one. Now we're going to go to our TFTP server, and our TFTP server is probably 15. Yep, B15. And so hopefully you guys are seeing the similarities and kind of seeing how we actually can see the address in IP version 6. So /64 just says our first 64 bits all have to be the same to be in the same network. Okay, that is the most basic way of explaining that. And so these host bits represent 64 host bits. The network itself could be represented like that, where it's just all zeros. So anything that we put on there is a host after that, starting with 1 and going to a lot. But anyways, 64 FE80 : 1. Alright, so that's our IP version 6. So now we get the fun stuff. Design an IP version 6 addressing scheme and complete the addressing table based on the following requirements. Use the table to help you organize your work. Alright, so the nice thing about this, once again, so maybe you want to get these instructions no matter what, is we can actually just write in this table. So, A, the subnet 192.168.24 network provides 30 host addresses per subnet while wasting the fewest addresses. Alright, so 30 addresses means that this one stops at 192.168.1.31. Okay, so it's masked for /32. Well, let's think about it. The /24 gives us 254 hosts, or let's just say 256 if this says 30 usable, right? We can determine that. So our next one, /25 would give us 128. A /26 would give us 64. So this is a /27. So /27 is 8 bits there, 8 bits there, 8 bits there, and then 3 bits there, or a 224. And if we add that, that gives us 250s, or 223, I'm sorry. Anyhow. No, it is /224. I don't know. I guess my head's in other places right now. Anyways, /224, if we minus 256 minus whatever we get, it'll show us our block size, so that gives us 32, 30 usable. I don't know what they mean. Assign the last network host to G00. Okay, so G00. We'll go back there. G00 is going to be assigned last highest, 168.1, and if you said 31, remember that's the broadcast, so it is 30. Wait. Yeah. It should be 30. Okay, so, oops, let's bring that back over there. And that said G00, right? Where's my Word document? Sorry about that. Okay, so it did say, oh wait, so first it says assign the fourth subnet. Oh, okay, I skipped step. It says assign the fourth subnet to the IT department. Alright, so this one would be .32. This one would be .64. So this one should start with .96, and it would go to, let's see, 127. And I got that. It's all by adding 32, and this one is 128 would be the next network, so we subtracted 1. Same subnet mask for all these subnets. So now we get back there. Assign the last network, the highest, to that. So that would be 126. So Good thing we didn't assign the other one. So I'll throw this over here. And we're going to go config T, interface G00, IP add 192.168.126.125.255.255.254. We've already turned that interface on, so that's all we have to do there. So, come back to this. Starting with the fifth subnet. Subnet that works, so the new subnets are /14s. Okay, so they're going to have a total of 16. So we need to find what supports 16. So a 2224 supported 32. If we go one more bit, or a /28, it will support 16, and that gives us /255.255.255. That's /24, right? So we need to add 4 more bits. That gives us a 240. So this one starts with 128, and it will go. Its next network is, what is it? Okay, 16. What is it? 144, I believe. 140. Yeah, that seems right. So this one ended at 143, and this one ends at 160. Actually, that's a 159 would be the broadcast. Same one. Okay, so that's the administrator LAN. So we want to do first the G00, assign the last host address. So the last host address for that would be 158. So hopefully we did our math right, and it is 158. So interface G01, IP add 192.168.158 255.255.255.240 or /28. And the reason I talk in prefixes, if you ever wondered, if you want to see what your routing table knows, you do a show IP route, and as you can see, these directly connected show a /27 or a /27 network and a /28. They don't actually give you a subnet. Alright, so config T, back to our fun times. And actually, so might have messed up. If you're doing it, I forgot where I was going to do it this way, but I don't think you have access by double clicking, right, which simulates a console. So if you ever need to console in, what we do, we're going to go in the IT host to the serial, the RS-232, and then we're going to plug into the console cable here, go into terminal emulator, and it puts us back in the same spot because we were virtualizing a console, but that is locked out in the actual exam. So if you got that working, then it wouldn't work there. Assign the second to last address to the subnet. So we did 158, so now we need 157, and that is going to go on this switch. Interface VLAN 1. That's an SVI. That's how we manage this switch. Remember, switch is layer 2, but this is how we can telnet or SSH to it, and we'll be SSHing to it today. So, and then we're going to say no shut, and we're going to say IP address 192.168.157.255.255.255.240. Okay, and I'm going to do this a little early, but I'm going to say IP default gateway, because if we're going to SSH from our remote network, then we need a default gateway, and the default gateway is, once again, right on this side is going to be this router interface. The default gateway for these guys is going to be this router interface, which we're going to have to put in, I'm sure, in a second. So IP default gateway 168 1.158 was our default gateway. And so we have that part done. What is next? Configure addresses on the host using any of the remaining addresses in the respective subnets. Alright, well, I'm going to use we used the last, so I am going to use the first. So the first on this one is 192.168.1.97, and it's given us a /24, so make sure you fix that subnet. We need a 224 in there, and we need to put in a default gateway. And if you're doing this, I have all these computers blank on this assignment, so I'm just going to do all of them so that they work. I think you only have to, on this one, let's see, when it says assign, configure the addresses on the host to remaining respective subnets, I don't think in the assignment you have to do one of these sides. You only have to do one, but I'm doing them all. 192.168.1, and we used a subnet mask of, or what was our default gateway there? So it's that router interface, and on the router interface we use the highest of that network, which would be 126. So where is my error coming from? Why won't it let me close that error? Okay. Anyways, 192.168.1.126. Be my default gateway. Remember how I got that is it's this router interface right here to get out of, actually I'm in this computer, so it's this router interface. Hope I'm assigning them the right IP addresses. Right now the IT department, no, well, I'm not assigning them the right IT addresses. Alright, so hopefully you caught that before I did. This one would be 145. Its default gateway would be 158. Right? Yep. And so we're going to use 146 on the other one. And this is actually 224 subnet. 158 again. They're in the same network. We'll have the same default gateway. Let's make sure we change that subnet mask. Nope, we have it right. So I had that part right. Wait, no, that's a 240. So lots of problems here. Once we get the addresses, it will be much easier. Alright, so now we're back over here. So we want to go to desktop. And so 192.168 for the IT department. We're going 97, 1.97, not 197. And we're doing a 224 over here. And our default gateway was 192.168. 1.126. Okay, so in this one we're going to go 192.168.1 .98. Put a 224 on there and put in our default gateway of 1.126. Alright, so that's our addressing. So actually that's probably the hardest part for most people is that one. Alright, so the router, we're calling it middle. Host name middle. Nope, that's mid. If you ever wonder how I'm getting these commands to finish, that's me pressing tab. You will also see me doing question mark, just a help command telling me what commands I can issue at a certain instance. Anyways, protect the device from unauthorized access with an encrypted privilege exec password. Hopefully you guys remember that that's enable secret. This puts it in MD5 encryption and has a higher privilege level than just enable password. So we say enable secret, and I'm going to put in password 01 because it doesn't tell us what to use. Alright, so we have that secure all lines in the router. So if we wanted to see what was going on, we can do a show run. And if we go all the way to the bottom, it shows us our lines. So we have the line auxiliary, the line VTYs, and so the line VTYs, remember, are what we use for telnet and SSH. The line con 0 is console, and this is this emergency backup. So we probably have to do all of them that says all lines. So line con 0, we say password, and we say console1, login. I'm going to even do line aux0, I don't know that you have to, password, aux1, login, line VTY, 0 space 4, and we're just going to do password. You can see there's already a login, and we're actually going to change that by the end of this, and we're going to say password. Actually, we'll say SSH1, because we're going to be doing SSH here in a second. Okay, so require newly entered passwords must have a minimum length of 10 characters. Okay, so this is a hard one. This is a really obscure command, and we're going to do a question mark. Alright, and we're going to see what commands we have. And we have security. So we're going to try security. We're going to do a question mark. We're going to say passwords because that sounds like we want to do. Oh, minimum length. Guess what? That is, we want to make sure we have at least 10. It says set a minimum length. We're going to set it for 10. We probably couldn't put that password on our console anymore, but I would guess that would be actually for our enable password. Prevent all passwords from being viewed in clear text. Hopefully you remember that from the last one, service password encryption. Okay, so what that did is we do another show run. Our passwords were in clear text until we ran that. Now they look like these numbers. It's not a great encryption, but it's a real simple MD5 encryption. Configure the router to only accept in-band management connection over the protocol that is more secure than Telnet, as was done in the labs. Use a value of 1024. Alright, so this one is this thing we call SSH, and so it was kind of in this final chapter, but if you don't remember, there's some things we have to set. So first we have to set, and it doesn't give us this, so we're just going to set it ourselves, but we have to have a name on our device. We already have it. It's middle. So now we have to be associated with a domain to make an RSA key, which is a public-private key used for for SSH. So we say IP domain name, and whatever you guys want to put. itti.net is what I'm putting. And so I put itti.net, and now I can issue this command: crypto key generate RSA. So this is what actually makes our RSA command. And if you read down, it says may it use the value of 1024. So we use 1024 because to use SSH version 2, we have to be above 712, I think, or something. So we generated it, and I'm also going to say, I don't think you have to do this, but I'm going to say IP SSH version 2. So there we go. We have version 2 running. Now we're going to secure our line VTY 0 through 4 before we do the next, and we're going to say transport input SSH. This is going to only allow SSH. If we said transport input SSH, we try SSH first, and then we could actually put telnet in a real router, or in this we could put telnet, and then we could put SSH, but as this is just packet tracer, we can't do it. The best is to just use SSH because we want to use it because it's encrypted, not clear text. So our next deal, because we're not using any kind of AAA authentication, we could do that for this SSH, but we're just going to use our local account. So we're going to make a new account. We're going to say username netadmin and use a secret password of Cisco _ CCNA5. And they want the highest privileges. So we're going to actually do something else here. Netadmin privilege. Highest is 15. And we're going to say secret Cisco _ CCNA 5. Alright, so that gives us our privilege and gives us our local user. So why did we make this user? Telnet does not require a username, so we don't have to make a user for Telnet, but SSH requires a username. So now we go into our interface, line BT, oops, not interface, just line BTY 0 space 4, and we say login and then local. So it uses that local account. Before, remember, it was just login. So now we changed it to login local. And so now if you want to test your SSH, we say SSH, and we can SSH to either of our, so we can do a show IP route connected. That shows our directly connected routes. And so that is our networks, and so we can say SSH to either of our network devices. So we say 192.168, and if we want to show the, we'll just do a show full IP route, no connected, because it actually shows our local address. So we have 158 and 126. So we could SSH to either of those. 192, SSH 192.168.1.126. Okay, it doesn't like that. What do we have to do? Okay, so it makes us do it this way. Real device, you don't have to. -L was the one next. Login name, so that would be net admin, and then the IP address where we want to go. So once again, 192.168.1.126. Boom, it's open. We use the password of Cisco _ CCNA5. And look, we're in middle, which doesn't make sense because we were already in middle, but that's our first way of testing. We see that our other passwords are on there, but now we can test it from, let's say, this device, and we could actually go yeah, I'm not going to do it that way. Alright, so we'll just do it the same way. SSH -L net admin 192.168.1 dot. We'll do the other one now. What was it? No, we did 126. So we have 126, and what was our other device? I can't remember. 158. So we'll try the other side. Uh-oh. Ping 192.168.1.158. Alright, well, so we have a problem because that's actually our default gateway. So, did we do our math wrong? 146 and 158 should be in the same. Alright, are they in the same VLAN? They should be in the same VLAN. It's ping 192.168.1.45. No, we're 46. And I didn't put the one in, so that's probably another reason we're in trouble. Okay, so we can ping ourselves, but we cannot ping our default gateway. So we're going to hop back in our router and find out why. And so this is actually the console password, so we're going to say console1 because it's virtualizing console. And we say enable, that's password 01, that's what we put in there. So we're going to ping 192.168.1.158. Maybe I fat fingered the address. No, I did not. So let's now try to ping that device from the down end. Ping 192.168.1.146. Huh. Having some problems there. What's next? Alright, let's go back into here. So we're going to do a show run. I have this open. Show run. Alright. So what I think happened is when I set this up, I actually set these up inverse compared to my instructions, so I apologize if you guys are doing this way, but it's an easy fix. So if we look, this is actually G00, and G00 is the IT, is it? No, it's not. So that's not it either. Wait, yes it is. Okay, so G00 is actually set up in the IT network, and G01. So what we need to do is pull this one out. I'm going to put it in G02 for now. Then I'm going to take this one, put it in G00, put this one, put it in G01. So now they're plugged into the right devices so that they can get to the right networks. The router actually thought the networks were opposite of what they were, and that is a problem. So what a fun learning experience. This actually happens in real life all the time where you plug into the wrong cable. Well, probably not all the time, but it's happened to me, but it just happened to me right there. So let's try it now. And we gotta wait for this orange to come up. This is called spanning tree. It's making sure there's no layer 2 loops. It's running this little algorithm. We'll learn about that more in CCNA 3. Alright, so there we go. We have our pings going now. Thank goodness. Alright, so we're good to go there. That was a bad deal. So I think we have everything done there. We have the IP version 6. Reconfigure the link local addresses, the value shown in the table. We did that. Document the interfaces in the configuration file. This would have been nice, right? This would have helped me out. So what we do there is we say interface G00, which is the IT. We say description IT LAN interface, or whatever, I don't know, something like that. An interface G01 administration LAN interface. So something to tell us, oops, we didn't put description. So something to tell us what's going on there. And so where we're going to see that now is we do a show run. It tells us exactly what we have going on. So that is documenting those. Configure the administration switch. Alright, so we're going to go here. And we know the switch works because we just tried pinging. Configure the administration switch for remote management over telnet. We already did that, everything besides that. So if we do a show run, see, we put in that SVI, that'll allow us to do that. We put in a default gateway, that would allow us to do it for remote management. So all we have to do is put a VTY password in to actually do this. And I'm just going to name this switch as we go. Hostname, admin, switch. I don't know what they want us to name it. So then I'm going to say line, con, nope, don't care about the con right now. Line, VTY, sport, and probably if you're doing this on the realist, actually we're going to do a password on that one too. Password, telnet one, and then we're going to say line con 0, password console 1, and login just to lock up that console for security reasons. What else they want us to do? Verify, use the IP addressing from step 1 and the IP version 6 values provided. Table configure all hosts with correct addressing. Use the router interface and link local. So the IP version 6 default gateways on the host. Back up the configuration town hall router TFTP. Okay, so that's our next command. We're going back to our town hall router. We're going to look and see what we have here. It is our server has an IP address of 1.98. So what we're going to do is, so remember to save this, we either say WR or copy running config, startup config. That's how we save our devices here. Instead, we're going to also save it somewhere in case we, I don't know, this device sets on fire. So we say copy running config, or in this case we've actually saved it, so we could say startup config, whatever you want, to TFTP, and then we're going to press enter, and then it says address of the host name. So we want the IP address of the TFTP server, so it's 192.168.1.98. File name, middle config, sure. Let's see if it works. We might have to configure TFTP on there. Nope, it worked. So it copied when we saw these exclamation points. It says copied in 3 seconds, 400 bytes. It's pretty slow actually. There we go. So that's TFTP server. Use the default file name, and guess what? That right there is the jam. That is the entire thing. I hope you enjoyed it. I will I don't know that if you have any questions, let me know. Thank you.